Hello. Today we're going to look at another system of pulleys at the equilibrium. This one is a bit more complex, but nevertheless the ideas are the same. Again, we're going to consider the case where the pulleys are first weightless, and then we're going to move on to the case where the pulleys actually have the weight. Okay? So let's get started by reading the question together. The figure shows a system of pulleys in equilibrium. The weight of the block P1 is 200 newtons. Assuming that the pulleys are weightless, find the weight of block P2. Okay, so again, let's start by drawing or magnifying this image a little bit. So what do we have? We have 1, 2, 3, 4 pulleys and 3 weights, and they are in equilibrium, right? So again, let's just start from this side. It doesn't really matter if you start from P2 or P1. Let's start from this one. What do we have? Well, so this weight is being pulled by a tension in this rope, right? So you have force F pulling up. Okay, if this force is pulling up and this rope continues all the way down to here, so tension across everywhere in the rope has to be the same. Well, everywhere in this rope, okay? So this one is, for example, isolated rope. This rope has nothing to do with this rope. So tension here is F, that means tension here is going to be F, and tension here is going to be F as well, right? Now, what do we have here? So we have that F is being applied on this pulley. So this and this ropes, this and this parts of the rope must be applying a half F and half F to balance for this F, right? That means since the tension everywhere in this rope is the same, force here is going to be also F over 2. Well, now all we have to do is just relate these weights to these forces. So P1 is equals to F, right? So because this rope continues throughout here all the way to here. And X is being balanced by two forces, right? F and F. So X has to be equal to 2F and P2 has to be equal to F over 2. Well, just by looking at this equation and this equation, we can already tell that P2 has to be half of the P1, which is 100 newtons. Very simple, right? So now let's look at the case where actually the pulleys have a weight. So let's rephrase the problem a little bit. The figure shows a system of pulleys in equilibrium. The weight of block P1 is again 200 newtons and the weight of each pulley is 50 newtons. Find the weight of block P2. Again, let's get started by magnifying the image and let's look at what happens here. So P1, what are the forces on P1? So force, let's say F1 is pulling it up. Okay, so F1 is same throughout this rope, right? Because it's a continuous rope. Tension everywhere in the rope has to be the same. So you're pulling P1 with force F1, tension force F1, and then block X is getting pulled by two F1s. And now, when it comes to this, the force here is different, right? So let's call this for now F2. F2 here, F2 here, and F2 here. Now let's write down the equation. So for this one, it's very simple. So F1 is going to be equal to P1. And here is also somewhat simple because you have F1 and F1 pulling it up, and weight of the block X pulling it down, and weight of the pulley is pulling it down. So what you have is two F1s are being balanced by X and the weight of the pulley. Okay? Now here for P2, what do we have? For P2, we have F2 over 2, right? But for P2 we have F2, but we have to relate this F2 to this F1 here. So what am I going to do? Well, F2 is balancing this F1 and the weight of the pulley. So what I can write down, F2 and F2 has to be equal to weight of the pulley plus F1. Well, and then F2 is equals to P2. So I have to find the weight of the block P2. What is P2 going to be? P2 is going to be equal to F2, and F2 from this equation is just weight of the pulley plus F1 divided by 2, right? So that's what we have here, and F1 is equals to the weight of the pulley, weight of the block P1. So you have weight of the pulley plus weight of the block P1 divided by 2, or 50 newtons plus 200 newtons divided by 2, which is going to give us 125 newtons. So P2 has to be 125 newtons. I hope it's clear. So it's really important to realize that the slight difference between the two cases when pulleys have weight and pulleys are weightless. But the logic is the same, right? So we just consider the forces that are pulling things up and pulling things down, and we balance them. I hope this is clear to everyone, and thank you for your time.